Hey class, I've gotten an email from quite a few of you asking about the third homework question, which is number 30 from chapter 3, where we have this football player, this quarterback, in honor of the first weekend of the NFL. My wife's laughing at me since I chose a football problem for you guys. But anyway, there's this crazy quarterback that claims he can throw a football almost 200 meters. And so we are determined the angle that, or we're given the angle that he launches it at, and we're asked to determine whether or not this guy is making stuff up, or if he can actually, or if it's even feasible for him to throw at this kind of a distance. So this problem's a little tricky, so I wanted to give you guys a few hints on how to get started. So first of all, let's talk about the setup. So now, I kind of sketched the path, as you can see over here, and you can sort of think of this as having a few different locations. So we can call this location 0 where we start, we can call this up here location 1 when it's at its peak, and then down here we can call this location 2 when it reaches the ground. And we know a few things. For example, we're given this distance, maybe I'll call it D, the distance that he claims he can throw it. We don't know, though, for example, this max height here, H max, unfortunately. In fact, we know very little about the y direction, but we do know this angle, and we want to find this initial velocity. So, with that in mind, we can get things started. What I'm going to do is I'm going to consider this problem starting at point 0 and then going to point 2, since that's the distance that we've been given. You can do some tricks with looking at halfway as well in the max height, but I think this is going to serve us best. So let's go through and label our variables. X initial, based on how we drew this, we can call 0. X final, as you can see, is just this distance D. Y initial starts at 0. Interestingly enough, it's also ending at 0. So it looks like it goes nowhere in the Y, but it goes up and comes back down. The equation will still work even though these are both zeros. Sometimes that makes people a little bit nervous or wary. Now we don't know the initial velocity in the x or in the y, but since we know the initial velocity in the angle theta, we can still break it into the components. Instead of having two unknowns, v initial x and v initial y, we can just have one. So the x velocity we know is going to be the v initial. It's going to be the adjacent side, so multiplied by the cosine of the angle theta. And we know v initial y is going to be the v initial multiplied by the sine of the angle theta, since it's the vertical component here. Acceleration in the x we know is 0. Time we don't know, the hang time. V final in the y, I'm just going to leave it blank. We do know that it's just going to be the negative of v initial sine theta as a result of symmetry, but we don't need to worry about that. And acceleration in the y is just negative g, or negative 9.8 meters per second squared. So let's see, how can we go about trying to solve this? Well, let's see what we can do to find the initial velocity if we just start in the x direction with our distance. So we start in the x, and again we're looking from 0 to point 2, as I labeled. And the only equation when we have 0x acceleration that is going to be helpful is x equals x initial plus v initial in the x times time plus 1/2 acceleration in the x times time squared. Now this we set as 0. This we, oh no, that's not 0, sorry. This is 0 here. Maybe I'll get rid of my cross-out mark I just added there. Sorry about that. So what we're left with is our x, which is the distance d, is going to be equal to our initial velocity in the x, which is v initial cosine of the angle theta, multiplied by t. So now we don't know v initial and we don't know t. So let's look at the y direction and see if that helps at all. So let's look at the y, again from 0 to 2. Now I'm going to choose to use this same equation because I want to try to find another equation with v initial and time in it so that I can have two equations with two unknowns and use algebra to solve. So what we see here is using the same equation, y final equals y initial plus v initial y times time plus 1/2 acceleration in the y times time squared. We see that y final and y initial are both 0, and so what we have is 0 equals v initial y, which is v initial sine of the angle theta, times t, and then we have negative g is our acceleration, so I'll do negative or minus 1/2 g t squared. So now we know g, so g here, we know theta, and so again we have an equation with only t and v as our two variables. So we should, in theory, be able to solve, since we have two equations, we should be able to solve for our two unknowns. So you could, if you wanted to, solve this for t and plug that in this equation over here. So I'm going to leave it there. I trust you guys' algebra skills, but if you need any additional hints, let me know. Yeah, and I hope you guys find this helpful. Have a box-worthy evening, and I'll see you all tomorrow.